Good afternoon. Today we are continuing on with those variables. We're going to be remembering what we talked about with Po60, with combining those like terms, simplifying it down. And we're going to be working on Po61. I can solve multi-step equations. So in previous unit, we did opposite operations with the multiple, we were either multiplying or dividing, or we were adding and subtracting. Then we did 2 steps where we did the adding or subtracting, and then we did the multiplying or dividing. Now we're doing multi-step equations. So we're adding in what we just learned and then doing those opposite operations. Whew. So it's not brand new, it's just using what we've learned in other objectives and putting it all together for this. So to solve multi-step equation, it is an equation with more than 2 steps. We're getting into the hardy, meatier pre-algebra stuff, right? This is taking us into algebra. We need this for next year. We're combining all these different steps now to be a multi-step equation instead of just focusing on the 2 steps or just focusing on the simplifying, combining those like terms. Now we're going to be doing all these different things, which you know how to do, but we're doing them all with the same equation. So it's lots of steps, lots of details. So it's just like last unit, I said we cannot rush through this. We have to go step by step and pay attention to our details. Okay. Still true, algebra is very detail oriented. I like details, so I find this really fun. Once you have it mastered, you're like, oh, if I do it step by step by step, it becomes easier and it can be fun going from a big equation down to a 1 number answer. But we have to be diligent that we're paying attention to our details so we're getting that right answer. So there are 3 concepts we're going to focus on that make an equation multi-step. Combining like terms, which we did in Po60, the distributive property, which we did in Po60, and in Po62, having variables on both sides. So that's coming up next. We're going to see what happens. Instead of just having the equals a number, you're going to have a variable over here, you're going to have a variable over here, and how do we solve that? So those are things coming up. All right, so combining the like terms, your goal is to simplify the equation by combining like terms. So it's simplifying. Just like when we simplify fractions, that final step, we have to simplify it. Same thing with equations. You have to simplify, combine those like terms. You can't have 12n plus 2n. You can't leave it like that. You have to combine all the like terms that you can. So when combining like terms, you are only working with one side of an equation. You're on the same side, so we do not use opposite operations. Opposite operations is when we move something to the opposite side of the equal side. Same side, you use the same operation. Opposite side of the equal sign that we're moving it to, we use opposite operation. So if we're combining like terms that are on the same side, you do the same operation. When we have to move stuff to the opposite side is when we do opposite operations. So that is a big thing that you have to keep in mind. Same side of the equal sign, same operation. If you're moving to the opposite side of the equal sign is when you do the opposite operation. So let's see how that works. I'm going to scroll up. Well, let's look at this first one. 6x plus 4x equals 50. What's my first step going to be? Henry?
Combine like terms.
Combine my like terms. 6x plus 4x gives me 10x equals 50. Notice how I'm trying to line it up. Equal sign under the equal sign. I'm trying to keep it organized. What's my next step going to be? Joe? Yeah, I need to find my value for x. How do I do that? Joe? Oh, I need to move the 10 to the opposite side, so I'm left with just an x. To move to the opposite side, we do our opposite operation. This is multiplying, so I need to divide both sides by 10. 10 divided by 10 is that 1x. 50 divided by 10 is 5. We need to make sure that we are showing our work. Could we have done that in our head? Yeah. We could have. Are we going to get to way more complicated problems that we're going to make mistakes if we try to do it in our head? Yep. So that's why we're saying show your work. Even though it's a simpler one that we could do in our head, I actually want you writing it all out so we can make those good habits. We want to form the good habits with the easier problems, so the harder problems are easier for us to do. Okay, so really, truly show your work. You're going to show every step. If I put it on the board, you're doing it on your paper. We are not doing mental math anymore. Okay, no gold stars for mental math. Show every step. And when I say I line it up to keep it organized, I want you lining it up. I have had times where I've had students come at this and they do an equation on the left and then they do another, they combine over here and they do opposite operation there and then they come, and when you don't stay organized, that's when I see a lot of mistakes happen. And I know what's coming up in future math problems. I've showed you that example from Mr. Schultz with crazy equations on it. We have to stay organized so we don't make those mistakes. Let's look at this one. Negative 8x plus 5x equals negative 12. What's my first step?
Add negative 8x to 5x.
Yeah, we have to combine those like terms. What is negative 8x plus 5x, Colton?
Negative 3x.
Negative 3x. And that equals negative 12. What's my next step? Keep it going, Colton.
Divide by negative 3.
Yeah, because I want that x by itself. Now, here's a mistake I've seen a lot of people make. It's negative 3 up here, but you only divide by 3. Make sure you keep that negative 3 there, because negative divided by a negative gives me a positive. Negative divided by a negative is going to give me a positive 4. Okay, that's a common mistake that people make. They forget that negative. So make sure you're carrying that through. Does anybody know how we could check our work to see if we did it correctly? How do you think we check it, Victoria? Say that one more time for me. If I say x equals 4, I can fill that in for my x. And we can see, does it really equal negative 12? So negative 8 times 4 is a negative 32. 5 times 4 is a 20. Negative 32 plus 20 is negative 12. Oh, look at that. I did my math right, both sides balance. Negative 12 equals negative 12. So is it a good idea to check your answer? Especially on the test, right? Because we want to make sure we did it correctly. So practice checking your answer. Whatever you get for x, put it back in your equation. Work through the equation. Does one side balance with the other side? Okay, so you can check through your work. Make sure you're doing it correctly. If they're two different numbers, you know you messed up somewhere. Typically it's with that negative, okay? Let's look at our next one. 18n minus 10n plus 2 equals 90. What's my first step? I know Colton can do it. He's been brave already. He did one for us. Let's get somebody new. Ellen.
Negative 18 minus 10. Or 18n minus.
18n. We're going to combine that. 18n minus 10n. What does that get me, Ellen?
8n.
8n. Now, this is important. What do I have to do with that plus 2? I have to bring it down from my equation, right? So I have to bring that plus 2 down. So now I have 8n plus 2 equals 90. Now we're into that two-step opposite operation. What is that first step of my two-step? We've done two-step opposite operations, solving for n. What should I do, Elliot?
Subtract 8 from 8n for 8n.
Not yet. No. When we did two-step operations, remember we were doing Sadmer. So we need to look for just straight up adding or subtracting. That 8 has an n after it, so that's a multiplying. So what step should I do, Joe?
Divide.
Nope.
Add.
Gavin, were you raising your hand or were you just stretching up?
Raising my hand.
What should I do?
I was going to say add.
So 8n plus 2 equals 90. If I need to do opposite operation,
Subtract.
what am I going to subtract?
8 or no 2.
The 2! I need to do that. This has multiplying with it, so that's my second step. Here it's plus 2. I need to do my opposite operation of subtracting 2. 2 minus 2 is 0. So I'm left with 8n equals 90 minus 2 is 88. Now what's my next step? Ellen?
Solve for n.
I need to solve for n. How do I do that? Remember, two-step opposite operations. Now I'm doing that multiplying or dividing. Yeah, this is multiplying by 8, so I need to divide both sides by 8. 8 divided by 8 is 1. 88 divided by 8 is 11. N equals 11. So we did these two steps a while ago. You know two-step operations. Add, subtract, then multiply or divide, doing those opposite operations. You know this. We're getting a little deer in headlights. I can see it. Some of you are going, oh my gosh, what did you just do? I just did math that we've already mastered. You guys have all mastered that objective. Okay? We're just combining it with our combining like terms. Don't be scared by it. It's the same math that we have done. Let's look at our next one. What's my first step going to be? Have you walked me through one already, Joe?
Maybe.
Henry, have you walked me through one? No. All right, we're going to go with Henry because I think you already walked through some. Henry, walk me through what's my first step.
Then combine my terms.
Okay, so what should I combine?
Do 10n minus 2n,
10n minus 2n gives me what, Henry?
8n.
Okay,
Then you should combine the other constants.
yeah, I have another set of like terms. I have my variable of n like terms, I combine those. Now I have my constants are like terms, and I need to combine those. So what do I get for my constant?
10. If you combine
Plus or minus?
them. Oh, what?
Plus 10, because they are positive. 7 plus 3 is a positive 10, so plus 10 equals 2. Does that make sense? Show me your thumbs. Are you good with the first step? Okay. What's my next step? Emily.
Subtract 10 by 10 and 2.
Yes. I need to do that first step of Sadmer. I have a plus 10, so I need to subtract 10 from both sides. 10 minus 10 is 0, so I have 8n equals, what's 2 minus 10, Emily? Negative 8. What's my next step? Joe?
Divide by 8 out of 8n.
Again, opposite operations. If I'm multiplying, I need to divide. 8 divided by 8 is 1. Negative 8 divided by 8 is what, Joe?
Negative 1.
Okay, so like I said before, we know our two steps of opposite operations. Now we have a new first step. That new first step is combining like terms. Then we do our two-step opposite operations. So we know combining like terms from yesterday. We know our two-step opposite operations, but we're getting a few more steps added in. Okay. Let's look at that distributive property. The goal of the distributive property is to eliminate parentheses. We worked on that yesterday. We wanted to get rid of those parentheses, so we multiplied through that number that was on the outside of the parentheses, so we could take off the parentheses. So that's the, now I'm giving us another new first step. Parentheses, if you have them, is your first step. Doing that distributive property. Then, what would our second step be? Think about what we did here. What's our second step? Colton?
Combine like terms.
Combining like terms. Okay, so we have yesterday's objective, getting rid of that distributive property, getting rid of the parentheses. Then we have combining like terms. That's all on the same side of the equal sign, so it's same operations. Then we do our two-step opposite operations. We do our opposite of adding or subtracting, then we do the opposite of multiplying or dividing. So holy Hannah, some of these are gonna have 4 steps to them. You really have to go slow and make sure you're paying attention to those negatives and how to add or subtract with negatives. Okay. Simple mistakes that people make working with those negative numbers. So let's see how we can work this through. Remember, distribute the coefficient to everything in parentheses and multiply, don't add. So when we distribute that 7 through, we do 7 times the n, 7 times -5. Pay attention to your signs. When we get to this one, that 3 isn't a 3, it's a -3. Keep the sign with the number. Who is gonna be brave?
Oh.
What's my first step? I saw Colton's hand first. He's itching to do this. Walk me through the first step, Colton.
So you're gonna do 7 times n, you get 7n, and then 7 times -5, and you get minus 35. And then you're gonna add
Oh,
30.
hold on.
Oh, equals 42.
Yeah, we can't forget to bring down everything from that first equation. So you rewrite it all. 7n minus 35 equals 42. Next step, Colton.
Plus add 35 to 35, and then add 35 to 42.
Negative 35 plus 35 is a 0. So I have 7n equals what, Colton?
77. And then divide 7 by 7, and then divide 77 by 7.
Because I was multiplying 7 times n, so I need to do the opposite. 7 divided by 7 is 1. 77 divided by 7 is what?
7. We know, 11.
So it's little steps. Okay, Colton, at first he's like, oh, 77 divided by 7 is 7. And then he would have gotten n equals 7. How would Colton have figured out that he made a mistake? Colton?
Checking your answer.
Checking your answer. He could take the 7 and put it back in there. If he had kept that 7, we would have had, so 7 minus 5 is 2. 7 times 2 is 14. He would have said, oh, snoikies, that doesn't look right. 14 does not equal 42. Uh-oh, I went wrong somewhere. That's why it's important we check our work, because it is that easy to make a mistake, right? 77 divided by 7, we've got all these 7s flying around. It's easy to say, oh, n equals 7, got it. But when we check our work, we could say, oh, that's not right. And he would go back and go step by step. Where did I make the mistake? And go, 77 divided by 7 is 11. So now let's work it out with the 11 in there. So we have 7 times 11 minus 5 equals 42. I know I do my parentheses first. 7 times 6 is 40. Oh, look at that. 42 really does equal 42. That's why it's important to check your work. Take what you think your answer is, put it back into the original equation, and truly do the math. Don't just assume it's right. Actually work it through, and you can catch those little mistakes. So on the test, you're not making those simple math mistakes. Who can walk me through our next one? Victoria. You gotta be nice and loud for me, Victoria.
3 times -2x, 3 times 9.
All right, so what is 3 times -2x, Victoria?
6x.
Keep going.
Plus 27 plus 39.
Perfect. So we got that 3 times -2x is -6x. 3 times the +9 is +27 equals 39. What's the next step, Victoria?
Minus 27 and 27 and 39.
I'm going to subtract 27 from both sides. 27 minus 27 zeroes out, so I have -6x equals, what's 39 minus 27, Victoria?
12.
Okay, what's my next step?
Divide 6, divide -6x by -6. Yes. Well, divide 12 by -6.
So I'm dividing both sides by my -6. -6 divided by -6 is a +1. 12 divided by -6 is what, Victoria? -2. Let's check and see, did she do her math right? We're going to take -2 and put it into our original equation. All right, so first I'm going to do negative 2 times negative 2 is a positive 4, plus 9. 4 plus 9 is 13. Timesing that by 3 equals 39. So inside the parentheses, you're following your order of operations. You multiply before you add. So inside parentheses, you follow the same order of operations. 3 times 13 is 39. Okay, we got that one right. Next one. Who did this one?
Me.
So I'm gonna have Joe do the next one.
Right.
You're gonna start by combining like terms like add 2.
Before I combine like terms, what's the very first thing we look for? Parentheses comes first. Think of what perm does. Parentheses is always first. So if I'm looking at the parentheses, I need to distribute. That's going to be my first step. So what would that look like?
8 times n and 8 times n.
Okay, so what is 8 times n?
8.
What is 8 times negative 5?
Negative 4.
Okay. What else do I have to do to finish off this equation for this step?
Equals 1
What else do I need to bring down?
plus
2 plus. Okay, so make sure you're bringing down all the pieces of the original equation. We combined, did the distributive process, so we were able to bring that down, but we have to remember to bring down that 2 plus that's at the beginning. What's my next step, Joe?
You can combine like terms.
So what do I combine?
2 plus negative 40.
What is 2 plus negative 40?
Negative 38. And then you're gonna add 38 to
I need to finish off my equation.
8 and minus 38 equals 42.
So always remember to rewrite that whole equation. Whatever you haven't combined, make sure you're bringing it down. This was a positive 8n, so I bring down a positive 8n. If it was a minus 8n, I would have brought down a negative 8n. Always keep that operation with your number. Next step, Joe.
You're gonna add 38 to negative 38 and 142.
Minus 38 plus 38 gives me a 0. I bring down my 8n. What's 122 plus 38, Joe?
860.
Next step.
Now you're gonna divide 8 divided by 8 and then 160 divided by 8.
8 divided by 8 is 1. 160 divided by 8 is what, Joe? Yeah. 16 divided by 8 is 2. 0 divided by 8 is 0. Last one that we're going to work on together. I didn't go through to check the answer because I want to make sure we have some time to do this last one, but it all checks out. Who's going to be brave? Elliot.
First you can do 3 times 8 and
Am I doing 3 times 8n?
or negative.
Negative 3, because remember I said that operation stays with the number. So negative 3 times 8n and negative 3 times negative 1. Negative 3 times 8 is what? Make sure you keep that n with it. What's negative 3 times negative 1? Yeah, it's a positive 3. Then I need to bring down the rest of my equation. Oops. Bring down that equal sign. So I have 3n minus 24n plus 3 equals 3. What's my next step, Elliot?
Combine like
So what am I combining?
3n
Which becomes what? What's 3 minus 24? Not quite. Negative 21n. Then I bring down the rest of my equation, plus 3 equals 3. Next step. So 3 minus 3 is 0, so I have my negative 21n equals 3 minus 3 is 0. What do I do next? Divide both sides by negative 21. Negative 21 divided by negative 21 is 1. 0 divided by negative 21 is what? Can 0 be our answer? Okay. 0 is a number. If we're not sure, if we go, whew, I don't know if 0 can be my answer, let's go back and check it. 3 times 0 minus 3 times 8 times 0 minus 1 equals 3. So, okay, 8 times 0 is 0 minus 1. So that's negative 1. Bringing down 3 times 0 is 0 equals 3. Negative 3 times negative 1 is a positive 3. Oh, yeah, 0 can be my answer. Good job. Okay, so if you get an answer and you go, I don't know, can this be my answer? Take it, put it back in your equation and see. It may be right, it may not be. Put it back in to see first before we get all worried. Put it back in and check it. Okay. Do I have any questions on the steps? Am I being clear enough that you truly, actually have to do every step and write every step out? I sure hope so, because every year I have friends that say, Mrs. Gambino says we can't do mental math with this. I got it. Mrs. Gambino says we have to stay organized and do it this specific way, but my way works just fine. Guess what happens to those friends when they get up into algebra? Does it go just fine with them? Because they didn't learn the steps. Do the steps. I'm trying to prepare you for what's to come. Truly do the steps or you will continue to struggle. Remember, you need to come to me if you have questions, okay? Tomorrow is a Friday. It is a retake day. We have a lot of us wanting to do retakes. Okay. We are correcting this on, we don't have school Monday. We are correcting this on Tuesday. You cannot forget this is homework that's due on Tuesday. So I know we don't have work time right now, but can you ask me questions on it tomorrow? You bet. Should you do practice work for retakes tomorrow? You bet. There are a lot of steps we have to do for these 3 rows. Show your work, and oh, look at that. Check your answer. So you're gonna have to do the work, checking your answer, making sure you did your steps correctly. Then we have review at the bottom of the page. If you are watching this at home, I hope you are well, and I hope to see you soon. Shh, nope. I have not closed class because I'm still recording. We don't need to hear cheers on the recording. I hope to see you soon. Have a wonderful day.